There is absolutely something happening. There is something going on. Accelerated computing has reached the tipping point. General purpose computing has run out of steam. In this industry, it is not about driving down the cost of computing, it's about driving up the scale of computing. We would like to be able to simulate the entire product that we do completely in full fidelity, completely digitally. We would like to design it, build it, simulate it, operate it completely digitally. In order to do that, we need to accelerate an entire industry. Everything in our company has a digital twin. And in fact, this digital twin idea is really spreading, and it helps companies build very complicated things perfectly the first time. And what could be more exciting than climate? We would love to learn extreme weather. We would love to predict future weather at regional scales, at sufficiently high resolution, such that we can keep people out of harm's way before harm comes. Extreme weather costs the world $150 billion. It's not evenly distributed. $150 billion is concentrated in some parts of the world, and of course, to some people of the world. We need to adapt, and we need to know what's coming. And so we're creating Earth 2, a digital twin of the Earth for predicting weather, and we've made an extraordinary invention called CoreDiv, the ability to use generative AI to predict weather at extremely high resolution. The weather company is the trusted source of global weather prediction. We are working together to accelerate their weather simulation. They're also going to integrate Earth 2 CoreDiv so that they could help businesses and countries do regional, high-resolution weather prediction. Really exciting work. NVIDIA Healthcare. Something we started 15 years ago. We're super excited about this. Whether it's medical imaging or gene sequencing or computational chemistry, it is very likely that NVIDIA is the computation behind it. Today, we're announcing that we're going to do something really, really cool. Imagine all of these AI models that are being used to generate images and audio, but instead of images and audio, because it understood images and audio, all the digitization that we've done for genes and proteins and amino acids is now passed through machine learning so that we understand the language of life. Well, those models are incredibly hard for people to build, and so what we're going to do is we're going to build them. We're going to build them for the researchers around the world. And it won't be the only one. There'll be many other models that we create. Computer vision models, robotics models, and even, of course, some really, really terrific open source language models. Whereas large language models have the benefit of you providing your examples and then doing reinforcement learning human feedback. What is the reinforcement learning human feedback of a robot? Well, it's reinforcement learning physical feedback. That's how you align the robot. So that's how the robot knows that as it's learning these articulation capabilities and manipulation capabilities, it's going to adapt properly into the laws of physics. And so we need a simulation engine that represents the world digitally for the robot, so that the robot has a gym to go learn how to be a robot. We call that virtual world Omniverse. Now, I'm going to show you one super example of how AI and Omniverse are going to work together. The example I'm going to show you is kind of insane, but it's going to be very, very close to tomorrow. It's a robotics building. This robotics building is called a warehouse. Inside the robotics building are going to be some autonomous systems. Some of the autonomous systems are going to be called humans, and some of the autonomous systems are going to be called forklifts. And these autonomous systems are going to interact with each other, of course, autonomously, and it's going to be overlooked upon by this warehouse to keep everybody out of harm's way. The warehouse is essentially an air traffic controller. And whenever it sees something happening, it will redirect traffic and give new waypoints, just new waypoints to the robots and the people, and they'll know exactly what to do. This warehouse, this building, you can also talk to. Of course you could talk to it. Basically, the system I just described will have Omniverse Cloud that's hosting the virtual simulation, and AI running on DGX Cloud And all of this is running in real time. And so the way you integrate software in the future, CI/CD in the future, for robotic systems is with digital twins. We've made Omniverse a lot easier to access. We're going to create basically Omniverse cloud APIs, 4 simple API and a channel, and you can connect your application to it. And with these APIs, you're going to have these magical digital twin capability. We also have turned Omniverse into an AI and integrated it with the ability to chat USD. Omniverse's language, as it turns out, is Universal Scene Description. And so you can speak to it in English, and it would directly generate USD. And it would talk back in USD, but converse back to you in English. And so you could ask it of certain objects or certain conditions and certain scenarios, and it can go and find that scenario for you. It also can collaborate with you in generation. You could design some things in 3D, it could simulate some things in 3D, or you could use AI to generate something in 3D. Let's take a look at how this is all going to work. We have a great partnership with Siemens. Siemens is the world's largest industrial engineering and operations platform. You've seen now so many different companies in the industrial space. Heavy industries is one of the greatest final frontiers of IT. And we finally now have the necessary technology to go and make a real impact. Siemens is building the industrial metaverse. And today we're announcing that Siemens is connecting their crown jewel accelerator to NVIDIA Omniverse. From the beginning of your design, to engineering, to manufacturing planning, all the way to digital twin operations. Once you connect everything together, it's insane how much productivity you can get. All of a sudden, everybody's operating on the same ground truth, from the design department to the art department, the architecture department, all the way to the engineering and even the marketing department. And it's all because it's connected by all these wonderful tools and these developers that we're working with. That was not an animation, that was Omniverse. Today we're announcing that Omniverse Cloud streams to the Vision Pro. And it is very, very strange that you walk around virtual doors when I was getting out of that car, and everybody does it. It is really, really quite amazing. Vision Pro connected to Omniverse portals you into Omniverse. And because all of these CAD tools and all these different design tools are now integrated and connected to Omniverse, you can have this type of workflow. Really incredible. Let's talk about robotics. Everything that moves will be robotic. There's no question about that. It's safer, it's more convenient. And so these autonomous robotic systems are software defined. They take a lot of work to do. Has computer vision, has obviously artificial intelligence, control and planning, all kinds of very complicated technology, and takes years to refine. We're building the entire stack. However, we open up our entire stack for all of the automotive industry. This is just the way we work. The way we work in every single industry, we try to build as much of it as we can so that we understand it, but then we open it up so that everybody can access it. You probably don't know this fact, that we have over 1 million robotics developers. We created Jensen, this robotics computer. We're so proud of it. The amount of software that goes on top of it is insane. But the reason why we can do it at all is because it's 100% CUDA compatible. We call Jensen a robotics computer. We also today are announcing this incredibly advanced new SDK. We call it Isaac Perceptor. Most of the robots today are pre-programmed. They're either following rails on the ground, digital rails, but in the future, they're going to have perception. And the reason why you want that is so that you could easily program it. You say, would you like to go from point A to point B, and it will figure out a way to navigate its way there. So by only programming waypoints, the entire route could be adaptive. The entire environment could be reprogrammed, just as I showed you at the very beginning with the warehouse. You can't do that with pre-programmed AGVs. If those boxes fall down, they just all gum up and they just wait there for somebody to come clear it. And so now, with the Isaac Perceptor, we have incredible state-of-the-art vision odometry, 3D reconstruction, and in addition to 3D reconstruction, depth perception. The reason for that is so that you can have 2 modalities to keep an eye on what's happening in the world. Isaac Perceptor. The most used robot today is a manipulator, manufacturing arms, and they are also pre-programmed. The computer vision algorithms, the AI algorithms, the control and path planning algorithms that are geometry aware, incredibly computationally intensive. We have made these CUDA accelerated. So we have the world's first CUDA accelerated motion planner that is geometry aware. You put something in front of it, it comes up with a new plan and articulates around it. It has excellent perception for pose estimation of a 3D object. Not its pose in 2D, but its pose in 3D. So it has to imagine what's around and how best to grab it. We call it Isaac Manipulator. And they also just run on NVIDIA's computers. The next generation of robotics will likely be a humanoid robotics. We now have the necessary technology to imagine generalized human robotics. In a way, human robotics is likely easier, and the reason for that is because we have a lot more training data that we can provide the robots because we are constructed in a very similar way. It is very likely that the humanoid robotics will be much more useful in our world because our workstations and manufacturing and logistics, they were designed for humans, they were designed for people. And so these humanoid robotics will likely be much more productive to deploy. While we're creating a foundation model that learns from human examples. It could be in video form, it could be in virtual reality form. We then created a gym for it called Isaac Reinforcement Learning Gym, which allows the humanoid robot to learn how to adapt to the physical world. But there's a bonus. When you become accelerated, your infrastructure is CUDA GPUs. And when that happens, it's exactly the same infrastructure for generative AI. One of the industries that benefited tremendously from scale, you all know this one very well, large language models. We were able to scale large language models at incredible rates, effectively doubling every 6 months. And here we are, as we see the miracle of ChatGPT emerge in front of us, we also realize we have a long ways to go. These models are groundbreaking. However, it's hard for companies to use. How would you use it? How would you bring it into your company and integrate it into your workflow? How would you package it up and run it? How would you do the optimization for each and every one of these models and put together the computing stack necessary to run that supercomputer so that you can run these models in your company? And so we have a great idea. We're going to invent a new way for you to receive and operate software. This software comes basically in a digital box. We call it a container. And we call it the NVIDIA Inference Microservice, a NIM. And I'll let me explain to you what it is. It's a pre-trained model, so it's pretty clever. And it is packaged and optimized to run across NVIDIA's install base, which is very, very large. What's inside it is incredible. You have all these pre-trained, state-of-the-art open source models. It is packaged up with all of its dependencies. So CUDA, the right version. cuDNN, the right version. It's optimized depending on whether you have a single GPU, multi-GPU, or multi-node of GPUs. And it's connected up with APIs that are simple to use. Think about what an AI API is. An AI API is an interface that you just talk to. And so this is a piece of software in the future that has a really simple API, and that API is called Human. And these packages, incredible bodies of software, will be optimized and packaged, and we'll put it on a website. And you can download it, you could take it with you, you could run it in any cloud, you could run it in your own data center, you can run in workstations if it fit, and all you have to do is come to ai.nvidia.com. We call it NVIDIA Inference Microservice, but inside the company, we all call it NIMs. Someday, there's going to be one of these chatbots, and these chatbots is going to just be in a NIM. And you'll assemble a whole bunch of chatbots. And that's the way software is going to be built someday. How do we build software in the future? It is unlikely that you'll write it from scratch or write a whole bunch of Python code or anything like that. It is very likely that you assemble a team of AIs. There's probably going to be a super AI that you use that takes the mission that you give it and breaks it down into an execution plan. Some of that execution plan could be handed off to another NIM, and then it comes back with its answer, and it presents it to you. We can get a report every single day at top of the hour that has something to do with a build plan or some forecast or some customer alert or some bugs database or whatever it happens to be, and we could assemble it using all these NIMs. And so we decided, this is such a great idea, we're going to go do that. And so NVIDIA has NIMs running all over the company. We have chatbots being created all over the place, and one of the most important chatbots, of course, is a chip designer chatbot. You might not be surprised, we care a lot about building chips. And so we want to build chatbots, AI co-pilots, that are co-designers with our engineers. And so this is the way we did it. So we got ourselves a Llama 2. This is a 70B, and it's packaged up in a NIM. And so we gave it a whole bunch of new examples. This is no different than onboarding an employee. We say, thanks for that answer, it's completely wrong. And then we present to them, this is what a CTL is, okay? And so this is what a CTL is at NVIDIA. And the CTL stands for Compute Trace Library, which makes sense. And so the productivity of our chip designers can go up. This is what you can do with a NIM. First thing you can do with it is customize it. We have a service called NeMo Microservice that helps you curate the data, preparing the data so that you could teach this, onboard this AI. You fine-tune them, and then you guardrail it. You can even evaluate the answer. And so that's called the NeMo Microservice. There are three elements, three pillars of what we're doing. First is having the AI technology. Second is to help you modify it. And third is infrastructure for you to fine-tune it and, if you like, deploy it. And so we are effectively an AI foundry. The other thing that you could teach the NIM to do is to understand your proprietary information. Remember, inside our company, the vast majority of our data is not in the cloud. It's inside our company. And so you essentially take structured data or unstructured data, you learn its meaning, you encode its meaning, so now this becomes an AI database, and that AI database, in the future, once you create it, you can talk to it. It's a smart database, and so you just chat with data. And how much more enjoyable is that? For our software team, they just chat with the bugs database. How many bugs was there last night? Are we making any progress? And then after you're done talking to this bugs database, you need therapy. And so we have another chatbot for you. You can do it. We even have NIMs of digital humans.
I'm Rachel, your AI care manager.
Okay, so it's a really short clip. She is a digital human NIM. And you just talked to her, and she's connected, in this case, to Hippocratic AI's large language model for healthcare. And it's truly amazing. And so just about every IT franchise, IT platform in the world that has valuable tools that people use is sitting on a gold mine for co-pilots. And they would like to build their own co-pilots and their own chatbots. And so let me finish up real quick. First, a new industrial revolution. Every data center should be accelerated. $1 trillion worth of installed data centers will become modernized over the next several years. Second, because of the computational capability we brought to bear, a new way of doing software has emerged, generative AI, which is going to create new infrastructure dedicated to doing one thing and one thing only. Not for multi-user data centers, but AI generators. These AI generation will create incredibly valuable software. A new industrial revolution. New type of software should be distributed in a new way so that it can, on the one hand, be an endpoint in the cloud and easy to use, but still allow you to take it with you because it is your intelligence. Your intelligence should be packaged up in a way that allows you to take it with you. We call them NIMs. These NIMs are going to help you create a new type of application for the future. Not one that you wrote completely from scratch, but you're going to integrate them like teams. And then lastly, everything that moves in the future will be robotic. You're not going to be the only one. And these robotic systems, whether they are humanoid, AMRs, self-driving cars, forklifts, manipulating arms, they will all need one thing. They need a platform, a digital platform, a digital twin platform, and we call that Omniverse, the operating system of the robotics world. This is what we announced to you today. Thank you. Have a great GTC. Thank you all for coming. Thank you.